Have you ever wanted to render your model in Blender as a blueprint drawing? You've come to the right tutorial. In this video, I'm gonna show you how to render the exact same blueprint as you saw in the introduction. And even if blueprints aren't your thing, you might want to stick around as I will show you how to use Blender's Compositor to render multiple camera angles in one go. Let's dive in. The first thing you need is a model, obviously. You can work on your own or you can download a model that I have used for this tutorial from mall.industry.siemens.com. Just browse through the product catalog. The model I'm using is the Zimatic S7-1200 controller. Type is 1214C. To download the model, click on the MCAD ECAD link, and when a window pops up, select the 3D model thumbnail. Then click on the CAD graphic and that will initiate the download. Blender can import step files, so you will need to convert the model. I have used convert3d.org. There you can upload your model and choose the source and destination formats. After the model is uploaded, it takes a little bit of time to process the model, and once it is ready, you can download the converted model in a zip file. Now, back in Blender, we can delete the default cube and also the light. Import your converted model and scale it down to 0.001 on all the axes. Now let's adjust the camera. In the View tab, select Lock Camera to View and adjust the perspective to your liking. Something like this seems to work for me. Change the render engine to Workbench. Yes, Workbench. You thought this was useless, right? It's definitely not. Enable the X-ray and set the slider all the way down to 0. Expand the Film tab and enable transparent background and also enable the Freestyle option. Then in View Layers tab, change the freestyle color to white, thickness to 2 and add a noise modifier in this tab. Influence is set to 0.125, amplitude to 2.5 and period to 5. This will create variations in the line thickness and make the strokes appear a bit more hand-drawn, not like the perfect CG-generated lines. Now add another line set and let's rename the original one to Visible Lines. And the newly created will be Hidden Lines. Change the color again to white, type will be hidden, then expand the freestyle strokes and enable dashed line. Set dash 1 to 20 and gap 1 to 5. Also decrease the thickness to 0.5 and add the same noise modifier as we did for the visible lines. That is 0.125 on the influence, amplitude is 2.5 and period is 5. Now let's render the image to see what it looks like. Now add a third line set, it will be called Guidelines. Uncheck the silhouette, crease and border and enable external contour. As always, change the color to white, thickness to 0.1, then for this one also decrease the base transparency to 0.5. Then go to Freestyle Geometry and delete the sampling modifier and replace it with Blueprint and change the shape to squares. Yet again, add a noise modifier to the thickness, this time with influence set to 0.25, amplitude to 2.5 and period the same 5. Let's take a look on our guiding lines and I think they look great. One more tweak in the Render tab, change the lighting to Matte Cap, then single color and actually increase the X-ray slightly to 0.025. This will create what I call a ghost volume and it kind of adds depth to the model. Change the scene name to Perspective and now make a full copy of the scene and rename it to Front View. Unlock the camera and click on the negative y-axis icon to get a front view. Then from the View menu, select Align Camera to View. In the Camera tab, change the type to Orthographic and actually adjust the scale to 0.214 or whatever works for your model. Let's take a look what the front view looks like, and I have to make a small adjustment in the perspective view. I want to extend the backbone length in the blueprint modifier to 75 and now do the same thing in the front view. Now let's create the rest of the views. So again, make a full copy of the scene, rename it to Side View, click on the negative X icon and then align the camera to view again. Let's render this. It may take a little bit longer time as there are the screw terminals in the model that are stacked on top of each other and it takes a longer time to compute the visibility. The guidelines seem to be over the top on the side view, so let's address that. Expand the Selection tab and check the Min 2D length and set it to 50. That will limit the guidelines to longer edges only. and that looks much better now. Let's copy the scene again and name it top view. Now click on the positive Z icon to actually change the look direction and align the camera to view, and let's take a preview what the model looks like from the top. For this one, we can actually remove the min 2D length condition, so make yet another copy of the scene, then select all the meshes and delete them. Add a text object to the scene, switch to edit mode, and in the text tab expand the font and replace the regular font face with Courier New. We can leave the rest of the faces as they are, as we won't be using them. Change the size of the text to something like 0.04, and now change the text itself to Siemens Zematic S7-1200, model CPU 1214C, DC/DC/DC, and the SKU 6ES7-214-1AGG40-0XP0. Now with the text object selected, align the camera to object, and with the camera selected, adjust the orthographic scale so that the text fits inside the camera frame. Now we can get rid of the hidden lines line set for the scene, and let's take a look. Two things here: the guidelines seem to be too excessive, and we are missing an infill. So we have to re-enable the min 2D length and increase it to 100. Also decrease the influence of the noise modifier in the thickness tab to half. Decrease the randomness of the blueprint squares to 3, and also shorten the backbone length to 25. Now to address the infill, go to the render tab. Set the lighting to flat and change the color to solid white and X-ray all the way to 1. Now let's actually check the rendered image, and I think that looks pretty good. I forgot to rename the scene, so let's fix that and change the name to text. Now copy the scene for the final time and name this one grid. Delete the text object, then unlock the camera and zoom out a little bit. Now add a cube and change its size to 1 mm on the x-axis, 1.8 meters on the y-axis, and 1 mm on the z-axis. Now go to the object menu and apply the scale. In the modifier tab, add a new modifier and select array from the generate group. Now change the type to fit length, and the length will be 3.2 meters. So where are the dimensions 3.2 and 1.8 meters from? Well, they are basically just doubled 16:9 ratio. 16 multiplied by 2 is 32, and 9 multiplied by 2 is 18. I have used one decimal point, so that's 3.2 and 1.8 meters. If you are using a different aspect ratio for your final render, you might want to adjust these drawings. For example, you could be using standard paper size aspect ratio, or photographic 3.2 ratio, or a square ratio. So it really depends on what you want your final render to look like. Now let's continue. Change the relative offset to constant offset, and the distance is 0.2 meters. Rename the object to thick vert. Duplicate it, abandon the translation, and rename the new object to thin vert. And change the distance on the x-axis to 0.05 meters. Now duplicate the thick vert lines, rename it to thick hor, or as horizontal, and delete the array modifier for the moment. Now rotate it with 90 degrees on the z-axis, change the y dimension to 3.2 meters, and actually apply the rotation and also apply the scale. Now change the object location to 1.6 meters, half of 3.2 on the x-axis, and negative 0.9 meters as a half of 1.8 meters on the y-axis. Then add the array modifier back and change the settings again to fit length. The length this time will be 1.8 meters. In the constant offset, zero out the x distance and change y to 0.2 meters. Now duplicate the horizontal lines object and rename it to thin hor, and just decrease the y distance to 0.05 meters. Now let's make two collections. The first one will be thick lines. Duplicate the collection and rename it to Thin Lines. Now move both the thick hor and thick vert lines to the thick lines collection and then the other two to the thin lines collection. Now in the View Layer tab, remove the guidelines and hidden lines and rename the visible lines to thick lines. Then change the base thickness to 0.25 and base transparency to 0.5. Now also remove the noise modifier from the thickness tab and limit the line set to the thickness lines collection. So select that one. Make a new line set. Select the thin lines collection. Then change the color to white. Base thickness to 0.1. Transparency to 0.5. With the camera selected, adjust the orthographic scale so that the grid fits completely inside the view. Then select one of the lines and in the View menu, select Align Active Camera to select it. That fits the grid perfectly in the render view. Now one more adjustment, decrease the X-ray all the way to 0 and we can have a look what the grid looks like. And surprisingly, it looks exactly how I wanted it to look. Yet one more time, click on the Add Scene button and select a new one. Rename it to Composite and go to the compositor layout. But before that, let's actually change the output resolution to 2560 by 14040. Enable the Use Node options and change the render layer node scene to the grid. Let's see what it looks like and add here a viewer node so that we have a live preview. So add a texture node from the input menu, click on the new button to add a new texture and rename it to Blueprint. Then add a mix color node from the color menu and then change the mode to Addition. Connect the texture node color output to the first input of the mix node, replug the outlets and connect the second input socket to the grid render. In the Texture tab, change the type to Clouds, noise basis is Voronoi F2, size is 0.04, increase the depth to 5 to add more details, and then in the Colors tab, enable Color Ramp. Select the first stop and change the color to hex code 37 for A94FF. Select the code and copy it to the clipboard, then select the other stop and paste the color code here. Make it a little bit lighter, then increase the contrast by dragging the first stop to the right side and then make the color on the second stop a little bit lighter again. You can play around with the texture if you want, I like it in this way. Now, copy the render layers node and change the scene to text. Copy again and select front view, then repeat the process for side view, also for top view, and then finally the perspective. To fit the views on the grid, we'll have to scale those renders, and for that I will use a transform node. Change the filter mode to bilinear and then copy the transform node for each render layers node and connect the respective image sockets together. Now we have to make a tree of the mix nodes, so let's copy and paste this node and connect the output of the previous one to the newly added node. And again repeat the process until you connect all the render layers node. Then separate the connection between the composite and viewer node and now reconnect it to the final mix color node that you have connected to the perspective layers node. Now we cannot see anything as we did not render the outputs yet, so let's change that, render the image, and after the rendering is done we can see that the images are stacked on top of each other, so we have to utilize the transform nodes actually to position and scale the views. Let's start with the text, scale it down to 0.4. The position is 800 on the x-axis and negative 550 on the y-axis. Actually click on the View tab and select Fit button to frame the entire preview in the composite window. The front view now will be positioned at 500 on the x-axis and 350 on the y-axis. The scale is the same, that is 0.4. Let's continue with the side view. The x-axis is 1050, y is 350, and the scale remains the same, 0.4. Top view will be placed below the front view, so the x-axis is 500 and the y-axis negative 200. Scale, you know the drill, is 0.4. Perspective view will take a dominant space, so I'll set the scale as 0.9, negative 600 on the x-axis and 100 on the y-axis. After seeing all the views on the blue background, I actually think that the ghost volume is somewhat too strong. So let's go to the individual views and decrease the X-ray value to 0.01. So in the front view, perspective, then side view, and of course the last is the top view. Now back to the composite scene and let's re-render the image to see the final result. Did you actually know how the original blue blueprints were made? Well, it's kind of similar to photography development. You would expose a paper covered in photosensitive substance through a tracing paper, a negative. Then the light turns the paper blue in the exposed parts, while the ink will block the light, leaving those areas white. Then you would wash the paper to stabilize the reaction and then let it dry. That was the original photocopy process to multiply the drawings from the original tracing paper. Well, I hope you guys enjoyed the tutorial. If you did, give me a thumbs up, and if you like what I'm doing here, subscribe for more upcoming content. See you in the next one.